Factor completely 6z squared plus 23z plus 7. So when we're factoring a quadratic of this form, where the leading term coefficient, which is the number multiplying the square, is not equal to 1, that generally means things are going to be a little bit tricky. We've got a lot of possibilities that could work out. Now, the factorization is going to be of the form a times my variable z plus b times c times my variable plus d, where a, b, c, and d are just constants, and z is the variable. Notice the form of this. This would look like mx plus b, which is a linear. So the product of two linears gives us a quadratic. So we're just trying to figure out what those linears are. Now, the only method of getting from here directly to this form is to use a guess and check method. And if one of the leading term coefficient or the constant happens to be a prime number, that's generally a time when I will try a guess and check method. Because the thing is, I know that because 7 is a prime number, that these two values have to be 1 and 7. Those would be the only two that multiply to 7. 6, however, 6 has a few different factors. We have 1 and 6, and we have 2 and 3. Usually, we have, I usually try the terms that are closer together first. It seems like in math courses, that's most of the time more common than the ones that are the extreme values, that are the 1 and 6, for instance. It's not a hard and fast rule, but it seems to work better that way. So that means the first two combinations I would try would be 2z and 3z. And I'm just guessing that the 2 would go here and the 3 would go there. Now, the only thing that we can do is just check to see if it works. How do we check? Well, we see if I can get the middle term to add up. So 1 times 3z would be 3z. 2z times 7 would be 14z. And even though these numbers do get large, the problem is 14 plus 3 would give me 17, which is not quite large enough to get 23. What can I do? Well, try other combinations. So instead of 2z and 3z, what if I did 3z and 2z? And you may think that that would be pointless because I've already tried those, but the two things that get multiplied are different. So 2z times 1 would be 2z. 7 times 3z would be 21z. Now I can get these to add up to 23. So this is the correct combination. I would need both of these to be positive, which means I need a positive here and a positive there. So my factorization is 3z plus 1 times the quantity 2z plus 7. Now, if you're not quite in tune with a method like that, another alternative method is to take the leading term coefficient and multiply it against the constant. So 6 times 7 is 42. So now you're looking for two numbers that multiply to 42 but then add to 23. And this is where all your guess and check resides. So let's see if we can figure this out. So 42 could be 1 and 42, but that's not going to work because you could only get 43 or 41 there. 2 and 21. Well, that would work. 2 and 21 multiply to 42 and also add to 23. And if they're both positive, then we're all set. And what we do is we decompose this middle term into 2z and 21z. We leave the 7 alone, and we leave the 6z squared alone. Now we factor by grouping. We purposely included 4 terms here. In the first set of terms, 6z squared plus 2z, there's a common factor of 2z, which would leave me 3z plus 1. In the second set of terms, 21z plus 7, there's a common factor of 7, which would leave me 3z plus 1. And what's important about that is this 3z plus 1 is a factor of both of these remaining terms, and so the whole factor, 3z plus 1, can factor out, leaving 2z plus 7. Notice we get the same answer either way. It's a matter of preference which way you want to go. But as I said, I tend to pick the method of guess and check if one of the leading term or the constant is a prime number, and then a method like this if that's not the case.